Assalamualaikum and hi, I'm Nurunajah binti Suhairi, number metric S72435. I will present about synthesis of highly porous hydrogels via inverse mini emulsions, polymerization of EGDMA and AA. For the research background, I use ethylene glycol dimethylcrylate (EGDMA), which is a diester synthesized through the condensation of two methylcrylate acid molecules with one ethylene glycol molecule. It serves as a monomer for creating both soluble and non-soluble polyethylene glycol dimethylcrylate or acrylic acid copolymer microspheres via suspension polymerization. Second monomer that I use is acrylic acid, which is known as AA, is an organic compound and the simplest unsaturated carboxylic acid. It is a colorless, flammable, and volatile liquid with mild toxicity. Primarily, acrylic acid is used in the production of polymers and is found in various industrial and consumer applications, including surface coatings, adhesives, and textiles. For the hydrogels are three-dimensional networks of cross-linked polymers known for their high capacity to absorb and retain water. Hydrogels with tailored porosity and properties can be synthesized through inverse mini emulsion polymerization for use in drug delivery, tissue engineering, water purification, and various other applications. The inverse mini emulsion polymerization, a water in oil heterogeneous polymerization technique, creates kinetically stable macroemulsions at or near the critical micellar concentrations. For objective, there are four, which is first, to synthesize highly porous hydrogels using inverse mini emulsion polymerization of EGDMA and AA. Second, to investigate the effect of surfactant type and concentration on the stability of the inverse mini emulsions. Third, to modify and functionalize hydrogels for specific applications. And lastly, to characterize the hydrogels using advanced technique. For the literature review, for the polymerization of PEGDMA and PAA is a quantitative analysis of microspheres with active carboxyl group on their surface, specifically polyethylene glycol dimethylcrylate coacrylic acid, which is PEGDMA CoAA, and polydivinyl benzene active coacrylic acid, which is PDVB CoAA. It is synthesized via distillation precipitation polymerization. The titration technique was used to evaluate the loading capacity of active carboxyl groups on the microspheres. Microspheres cross-linked with EGDMA exhibit a higher carboxyl group loading capacity and a lower contact angle compared to those cross-linked with DVB, indicating that PEGDMA CoAA microspheres are more hydrophilic than PDVB CoAA microspheres. For the inverse mini emulsion polymerization for drug delivery, polymer-based drug delivery system, which is TDS, have garnered considerable attention in the field of biomedicines, pharmaceuticals, and bio-nanotechnology. This system, particularly those with controlled therapeutic release and cell-targeting capabilities, offer the potential to treat various diseases, including cancer, while minimizing drug side effects. Among the different types of polymer-based TDS, microgels and nanogels are particularly promising. Microgels are small, cross-linked hydrogel particles, and when these particles are submicron in size, they are referred to as nanogels. Similar to hydrogels, microgels or nanogels are biocompatible, three-dimensional materials with high water content. For the methodology, I use scanning electron microscope SEM, thermogravimetric analysis TGA, sonication, and Fourier transform infrared spectroscopy FTIR for the characterization of the polymer. For the scanning electron microscope SEM, it is a type of electron microscope that examines the surfaces of microorganisms using a low-energy electron beam to focus on and scan sample. The creation of electron microscope was prompted by the limited effectiveness of light microscope, which are constrained by their longer wavelength, In contrast, electron microscopes have much shorter wavelength, allowing them to achieve higher resolutions. For the thermogravimetric analysis TGA, it is a technique used to measure change in the mass of a substance as it is subjected to temperature variations. During this process, the mass of the material is continuously monitored while it is heated or cooled in a controlled atmospheric environment. TGA is primarily used to study various thermal phenomena such as desorption, absorption, sublimation, vaporization, reduction, and oxidation. For the sonication, it is a process that uses energy to move particles within a given solution, typically for purposes such as cleaning or separating substances. It involves sending ultrasonic frequencies into a solution or sample, such as when cleaning jewelry to remove dirt and debris. Beyond communication, sounds become a valuable tool in shaping and understanding the world around us through this process. In scientific laboratories, sonication is primarily used for cell disruption. It helps to break down cellular membranes, releasing the contents of the cells, a process known as sonoporation. For the Fourier transform infrared spectroscopy (FTIR), it is the preferred method of infrared spectroscopy. In this technique, infrared radiation is passed through a sample where some of the energy is absorbed by the sample while the rest is transmitted through. The expected result of the inverse mini immersion polymerization experiment involving acrylic acid AA and ethylene glycol dimethacrylate EGDMA include the formation of uniform microsphere or nanogels with particle size ranging from 100 nanometer to 500 nanometer, depending on the emulsification and polymerization condition. These results will validate the efficiency of the polymerization method and highlight the tunability of particle properties, making the material suitable for applications such as drug delivery, water purification, or other biomedical uses. That's all from me. Thank you.